In this video, we will understand the architecture of Oracle database. It comprises of, first let's understand the physical structure of the Oracle database. This area you see is the physical structure of the Oracle database. So that is called the physical structure. Now this comprises of data files, control files, and the redo log files. You see these are the various processes which run in the background. They interact with the data files, and these processes talk with the memory. Any activity which happens in the memory is very much fast compared to any activity in the hard disk, and Oracle tries to do most of the activity in the memory. You see, this part was the memory of the database, and those are the various processes, and this is the physical file structure comprising of data files, control file, and redo log file. The control file contains the location of the data file, the redo log file. It contains very important credential related information. So if anyone does a change from the physical file structure, so those informations are stored in a control file, while a redo log file contains a redo entry for all the changes which takes place on a block. Let's see a physical file structure in an Oracle database. Say we query this table called dba underscore data files, and I query on the table dba underscore data files. I look for file name, and I can see the physical location of the files. You see this is the physical location of the data files, and so at this location you can see the data files are present. While let's see the location of the control file, and this is the control files of the database. And let's see the details about log file, and for that we query $log table, select a member from $log file, will show you the location of the log file. So all those files are the physical file structure of the database. Now to manage the database, say users are trying to access the database. What happens is the users connect to the server process, and the server process connects to the memory, and if the data is not present in the memory, the required data is retrieved from the data file and put into the memory. You see, these are the various background processes in the database, and you see this box here is the memory structure of the database. So let's understand more about the memory structure of the Oracle database. Let's start with database buffer cache. What happens is when a user retrieves the data, like say you fire a query like select star from a particular table, that data is stored in the buffer cache. Let's say user A fires a query. So when the user fires that query, see that he fires from the client machine. That query first goes to the query is taken first to the server process, so again I'll repeat, the client program repeats to the server process, and the server process checks in the buffer pool whether the particular data is already existing, and if the particular data exists, then it gives the data to the client. Si- if the data doesn't exist in the buffer cache, then what happens is the server process retrieves the data from the data file, puts it into the buffer cache, and the server process gives the data to the client process. So you understood what is the server process, what is a client process. The role of a server process is interacting between the client process and doing the required activities between the memory and the data files. So n number of users would be accessing the memory. So again, you understood that the clients don't connect to the database directly. They connect first to the server process, and the server process is responsible for executing that particular task. Now let's understand about shared pool. You see, this part is called the shared pool memory. Say, what does a shared pool contain? The shared pool contains, normally the shared pool will contain the SQL statement, the cursors, the stored procedure will be stored in the library cache, and dictionary related information will be stored in the row cache. So all those things are present in the shared pool. So when you execute a stored procedure, its compiled form is stored inside the library cache, which exists in a shared pool. So since that past code is already in the shared pool, if multiple users try to access the shared pool, the performance is fast.